Alright, Unit 1, Earth Systems. In this section we'll go over some objectives. We'll talk about Earth system science, Earth's 4 spheres, Earth's energy budget, cycles in the Earth system, biogeochemical cycles, and then also humans and the Earth system, so how we interact with our Earth system. As a warm-up, what is a system? Objectives. We're going to compare an open system to a closed system. We're going to list the characteristics of Earth's 4 major spheres. We'll identify the 2 main sources of energy in the Earth system. And we'll identify 4 processes in which matter and energy cycle on Earth. So starting things out, Earth system science. Some Earth scientists combine knowledge of several fields of Earth science in order to study Earth as a system. A system is a set of particles or interacting components considered to be a distinct physical entity for the purpose of study. So the Cliff Notes version of this. A system is a bunch of parts that interact with one another and we can study them. All systems have boundaries, and many systems have matter and energy that flow through them. Specifically for us on this planet, all systems that we talk about will have matter and energy flowing through them. So even though each system can be described separately, all systems are linked. A large and complex system, such as the Earth system, operates as a result of the combination of smaller, interrelated systems. So an example of a system. I am going to draw some pictures here. These pictures are the parts of a system. As a whole, we're going to kind of play Pictionary. I'm going to draw a bunch of parts to a system. You are going to raise your hand with those parts of the system, and we're going to take a guess as to what the overall system is based on the parts that I draw. So let's give this a try. Alright, so here's the first part to the system. And I am letting you know right now that my drawing skills are not going to be super fantastic. So there's the first part. Let's go on to the next part. Okay, there's the next part to this system. What is our overall system? Yes, sir? Chain. That could be a chain, I suppose. Not a ball and chain. That is not our system. Luke?
Water cycle.
The water cycle? Good guess, but no. We already said solar system, not the solar system. Not the nitrogen cycle. Not the ozone layer. Alright, let's continue on. Next part to our system. Remember, these are small parts to an overall system. These parts work together to create that system. Yes, sir? It is a pedal bike system. All right? It is the pedal bike. So we've got our sprocket, our chain, and our pedals. And if I would have kept going, I would have probably put the handlebars on there like this. And then I would have probably added a wheel And this is not a very good wheel. But all of these parts interact with one another in order to form the system as a whole. And the system as a whole is a bike. Now, this is important to add to this. Can a bike function without a person?
No. Yes.
No, it cannot.
Unless you put a robot on it.
We have to supply what two things in order to get a bike to go?
Energy.
Energy is one. Very good. What is another one?
Power.
Oh, that would be energy. Power would be like energy. Matter. We have to supply the person being matter and the energy from that person in order to get this system to operate. All right? Alright, the operation of the Earth system is a result of interactions between the two most basic components of the universe, as you guys just mentioned, matter and energy. Matter is anything that takes up space and has mass. Energy is defined as the ability to do work. It can be transferred in a variety of forms, including heat, light, vibrations, or electromagnetic waves. Our bodies take in matter. They convert that matter into energy through chemical processes. The energy that we release out of our bodies is heat energy. We interpret different forms of energy with different senses that we have. For example, our eyes interpret sunlight or visible light. Our ears interpret sound waves. Imagine how weird it would be if we could interpret light with our tongue. So in essence, you would end up being able to taste light. Or if you would be able to hear light. Kind of a weird concept to grasp. Our bodies are limited to understanding the external environment by the senses that we have. We use different technologies to interpret the external environment with the senses that we do have. So we can understand heat energy through using infrared light detectors. So we understand that heat energy by viewing them as a light source. A system can be described by the way that matter and energy are transferred within the system or to and from other systems. All systems interact. That is important for us to realize. All systems on our planet share matter and energy. And we describe those different systems based on how they interact with one another. There are two major systems that we're going to talk about when we talk about Earth system science. The first system is a closed system. That is a system in which energy, but not matter, is exchanged with the surroundings. So energy is going to be exchanged, no matter is exchanged. An open system also has energy being exchanged, but it does also have matter being exchanged. So an open system exchanges matter and energy with its surroundings. Your body is an example of an open system. You are breathing. You're taking in gases from the atmosphere. You are releasing different gases into the atmosphere. So you're exchanging matter. Solar energy is coming in contact with your skin. It warms your skin. So you are exchanging energy from the atmosphere as well. And then also you're releasing heat energy into the atmosphere. So an example here. On the left, we've got a closed system. On the right, we have an open system. And these two systems are made up of the same materials. On the left, during the summertime, maybe some of you like to do this. You take some tea bags, you put them inside of a bunch of water, go take the jar, close it up, put it out on a porch, there is no matter being exchanged. There's no evaporation occurring. There's not any more matter being added to it. There is solar energy, however, that is coming into that system. So solar energy is coming in, heat is released, but there is no matter exchange. So it is a closed system. Now if we were to take that same system, unscrew the lid, evaporation starts to take place, right? As evaporation is taking place, we're exchanging matter with the atmosphere.
Yeah, and doesn't it if you go in the water?
So matter is going to be released into the environment through evaporation. We are also going to add ice to this system, so that's adding more matter to it. The bags of tea are actually removed from that system, so matter is being released. Sun energy is still coming in, heat energy is still exiting, so we're still exchanging energy. Technically, all systems that make up the Earth are open. However, the Earth system as a whole is considered a closed system because the amount of matter exchange is very limited. Energy enters the system in the form of sunlight and it's released into space as heat. Only a small amount of dust and rock from space enters the system, and only a fraction of the hydrogen atoms in the atmosphere escape into space. Pop quiz, real quick. What types of matter and energy are exchanged between Earth and space? Yes, sir.
Dust and rock.
Dust and rock. Both of those are exchanged. What else? Hydrogen atoms are released off into space from our planet. Ty? Solar energy comes in and heat energy goes out. I think that covers most of them. Dust and rock come to Earth from space, while hydrogen atoms from the atmosphere enter space from Earth. Solar energy enters Earth's atmosphere and is re-radiated back off into space in the form of heat. I think that covers most of it. It's important to realize, though, that the Earth system as a whole is considered a closed system. Even though there's a very small amount of matter that is exchanged, the Earth and all the systems on it are open systems. All the systems that make up the Earth are open systems. Matter and energy are exchanged. This process of biological magnification. Biological magnification is the increase in the concentration of a heavy metal, so for example mercury, or organic contaminants, so chlorinated hydrocarbons, CBCs is an example of that, in organisms as a result of their consumption within the food chain or web. So organisms found at the bottom of the food chain are less susceptible to toxins found in the ecosystem. Because predators higher up in the food chain consume a larger amount of organisms carrying toxins, those organisms that are higher up in the food chain tend to gain more of these toxins within their body tissues. The toxins, when concentrated, become a health concern for organisms. So for you and I, and other organisms that are higher up in the food chain, like hawks, eagles, wolves, bears. Those organisms that consume a large number of lower order organisms tend to increase the concentration of these chemicals within their tissues, causing adverse health effects. So the organisms found at the top of the food chain who have consumed a large amount of the toxins tend to have a higher susceptibility to the negative effects of those toxins. The picture on the right shows phytoplankton, and it shows PCB concentrations in parts per billion. PCB was a chemical that was used for a very long time. PCB ended up in water systems. The water systems would then have microscopic phytoplankton. Those phytoplankton would absorb those contaminants. Now, when you are a phytoplankton, you don't consume a whole ton of those contaminants. You get a small amount of those. As we move up the food chain, we have zooplankton, and the zooplankton eat the phytoplankton. A zooplankton is not going to eat just one phytoplankton. he is going to eat as many of them as he can over the course of his lifetime. Then as we move even farther up the food web or the food chain, we get to the herring. The herring is not going to consume just one zooplankton. And because the zooplankton ate a ton of those phytoplankton, it absorbed a lot of the contaminants. The herring eats a bunch of the zooplankton. This increases the contamination level. Those contaminants end up in the tissues and the fats of the herring. Seabirds. Seabirds come in and they eat the herring, and they don't eat just one herring. So we increase or magnify the overall concentration of those materials again within the next level up in the ecosystem. Or it could be a porpoise or a salmon or some of those other organisms that are higher up in the food chain. As they eat more of those herring, more of those contaminants end up in their body tissues. This is the 2011-2012 Michigan Fish Advisory, and I believe that it actually has been updated and sections of it have been added to the fishing regulations now. So basically what this is it's a guide to explain some of the things that you are able to consume or how much you consume with regard to fish. The reason this guide is out there is because of this process of biological magnification. Some of the chemicals and some of the toxins that we have added to the environment are biologically magnified through the ecosystem, and as we get and consume those materials as we move up the food chain, those materials then are stored inside of our tissues. So if we scroll down on this, you'll see where it talks about the Michigan Fish Advisory. So it talks about some of our lakes and rivers are polluted with toxic chemicals like PCBs, dioxins, and mercury. So over the years, chemicals in the lakes and rivers can build up in fish. When you eat a lot of these fish, the chemicals can build up in your body as well. So the advisory goes on to talk about areas of the state where there's bodies of water that have been tested for these chemicals, where we see larger concentrations of these chemicals. One place that is notorious for some of these is the Pine River up around St. Louis. There used to be a chemical plant right there on 46, just outside of St. Louis. There's a big fence up, and the fence says EPA haul it away on the street, on the fence itself, on a big poster, I guess is the best way to call that, or bulletin board, right directly attached to the fence. And basically what it is an area where chemicals, because of that plant, were released into the Pine River. Those chemicals are then slowly absorbed into the ecosystem through this process of biological magnification. So it gives some restrictions on that area in particular, and there's other areas that gives more restrictions on. So it said who should eat Michigan, or who should use the Michigan Fish Advisory. People who eat a lot of fish caught in Michigan, pregnant women and families who have children under the age of 15, people with serious health problems. So those people should pay extra close attention to this advisory. It also says what can happen if you eat a lot of the fish with the chemicals found in them. And then it goes on to talk about the number of meals of fish that you should eat over the course of a month. So it talks about for adults, for children. It talks about a bunch of the different types of fish. Talks about how to correctly clean them in order to remove those chemicals so that then it's not as big of a problem. The mercury advisory goes on to talk about for men and women, and then for women and children. Talks about the number of meals per month that you should eat. So it says for women and children, 1 meal or less per month of one of the following. So these different species of fish. For men and women, so when it's talking about women, it's talking about women that are not either pregnant or nursing. So it talks about 1 meal or less per week. So you could have up to 4 meals of fish a month if you are an adult, male or female, and if you're female, not pregnant or nursing. Continues to go on and talks about the length of inches and what chemicals are associated with certain species of fish within Lake Erie, Barton Pond, Belleville Lake, and it continues to go on with a large number of those rivers and river systems and lakes found in the state. Let's find one that is close to us. Flint County. We'll try to find one in either Gratiot County or Clinton County. So right here's the Lake Huron tributaries. Right here's Pine River. Pine River, Elma Impoundment, Gratiot County. So it says species carp, PCBs. There's an abundance of PCBs found in these fish. The Pine River downstream of Elma, so from the dam down to down through Gratiot and Midland counties. It says all species from Elma downstream, all species of fish have large concentrations of PBBs and DDT. So it says general population length in inches. These contaminants are found in all fish, no matter their length. So it's probably in your best interest to not consume any fish out of that body of water due to this biological magnification and these two different substances that are found within the tissues of those fish. And it continues to go on with a large number of the other organisms and other bodies of water found throughout the state. It's broken up by the drainage basin, so Huron River drainage basins, Lake Michigan Basin, Lake Superior, Lake Erie, and so on. Earth basics. We're going to go through a number of just general facts about the Earth. We'll talk about its composition, and then we'll talk about the 4 spheres that make up our planet. Earth is the 3rd planet from the Sun. This is something you probably are very familiar with from 1st through 3rd grade science, where you talk about the solar system and where we're located in the solar system. The current scientific thought is that the Earth is about 4.6 billion years old. I am not going to hold you to dates. When I was in junior high, the Earth was believed to be 3.5 billion years old. So in 15 years, the Earth has aged 1.1 billion years.
Or they could have found out Evan submitted date back Carl.
Approximately 70% of Earth's surface is covered by a thin layer of water known as the global ocean. Earth is an oblate sphere, meaning that it is slightly flattened. The pole-to-pole circumference is 40,007 kilometers, whereas its equatorial circumference is 40,074 kilometers. So the equatorial circumference is about 70 kilometers larger than the polar circumference. And then Earth's average diameter is 12,756 kilometers. The interior of the planet A lot of our discoveries about the interior of the planet are based on scientific discoveries with regard to seismic waves. We measure waves as they bounce around on the inside of our planet. Imagine having a large boulder sticking out of a pond. And if you take a rock and you throw that rock in the pond, you're going to get waves that form from the rock you threw in. When those waves come in contact with the boulder that's sitting in the edge of the pond, it's going to deflect and move those waves of water. And we can study the deflection of waves and make some observations, even though we can't really dig down deep enough inside the earth to see exactly what is there. So by studying those waves, we make some predictions as to what the interior of the planet is like based on those seismic waves from, say, volcanoes or from earthquakes. Sometimes we can even study bombs going off and study seismic waves that are going off if the explosion is large enough. Seismic waves are vibrations that travel through Earth. They're caused a lot of times by earthquakes and by explosions near the surface of our planet. By studying the way that those waves travel through Earth, we've determined that Earth is made up of 3 major compositional zones and 5 structural zones. So the compositional zones of our Earth include the crust, which is the thin outermost layer of our planet. It lies above the mantle. Oceanic crust, it has a thickness of about 5 to 10 kilometers. The continental crust varies in thickness from 15 to 80 kilometers. The difference here is that we have to consider mountains. Mountainous peaks are going to have a much greater depth than, say, those areas that are close to sea level. The mantle. In Earth science, it's the layer of rock that lies between Earth's crust and its core. The mantle is about 2,900 kilometers thick. It makes up almost 2/3 of the composition of our planet. The core. The core is the central part of Earth that lies below the mantle. The center of the Earth is a sphere composed mainly of nickel and iron, whose radius is about 3,500 kilometers. The center of our planet is divided into 2 parts, the outer core and the inner core. The inner core is thought to be solid, the outer core is thought to be liquid. So, quick quiz. Explain why scientists have to rely on indirect observations to study Earth's interior. Why is it that we have to come up with some reasons or some ideas about what's on the inside of the Earth indirectly instead of directly? Okay, the depth is very hard for us to drill that deep. Very true. Any other reasons? Okay, why is it the only means necessary to come up with an observation for it? So, depth was mentioned. Is there another reason? Okay, too hot. If we get down that depth, we're going to have an increase in pressure, an increase in friction. Therefore, the temperature is going to be too high for anything that we could send down there to withstand. So indirect observations are the only means available for exploring Earth's interior at depths too great to be reached by drilling. Structural zones of the interior. The 3 compositional zones of Earth's interior are divided into 5 structural zones. The first one is the lithosphere. That is the solid outer layer of Earth that consists of the crust and the rigid upper part of the mantle. The rigid lithosphere is between 15 kilometers and 300 kilometers thick, and again, that is dependent upon the thickness of the crust where mountains are at. It's going to be much thicker in mountainous regions. It's going to be much thinner below the oceans. Underneath the lithosphere is the asthenosphere. The asthenosphere is the solid plastic layer of the mantle beneath the lithosphere. It's made of mantle rock that flows very slowly, and this allows the tectonic plates to move on top of it. So the lithosphere is basically the plates of our planet. The asthenosphere is kind of like a conveyor belt. It's plastic. It's kind of hard, but it's also kind of flexible and durable and movable. So as the asthenosphere works like a conveyor belt, it's going to move all of the material that's on top of it to new locations. This process is not going to happen very quickly. It's going to happen very slowly. We can actually use satellites to measure the movement of the plates. Many of our plates move about 2 centimeters per year. So it's a very small amount of movement. Many of our mountains actually gain height each year. So if you were to go out and climb Mount Everest this year, 10 years from now you could go climb it and go higher than you did this current year. The plastic asthenosphere is about 200 kilometers thick. The mesosphere, the mesosphere means middle sphere. It is a strong lower part of the mantle between the asthenosphere and the outer core. It reaches from the bottom of the asthenosphere to about a depth of 2,900 kilometers. Below the mesosphere is the liquid outer core that is thought to be mostly molten magma, molten rock. The outer core surrounds the inner core, and the inner core begins at a depth of about 5,150 kilometers. So this diagram is found inside your notes. It shows exactly what we just talked about. So it shows the crust, and the crust is part of the lithosphere along with the upper portion of the mantle. The asthenosphere is right below the lithosphere, and remember the asthenosphere causes the lithosphere to move. Below the asthenosphere is the mesosphere, and then the liquid outer core, and then the solid inner core. So those are the parts of our planet, the structural and compositional layers of our planet. And again, this picture shows exactly the same thing. We've got the mesosphere, the outer core, the inner core. Up at the surface, we've got the crust, the lithosphere, the asthenosphere. And remember, the asthenosphere is part of the mantle. So the mesosphere and the asthenosphere make up the mantle. Our planet also has magnetic properties. Earth's magnetic field extends beyond the atmosphere. It affects a region of space called the magnetosphere. This magnetosphere helps to produce the northern lights that we have on our planet. Scientists think that the motions within the liquid iron of the Earth's outer core help to produce some currents, some electrical currents. And as those currents are created, it creates this overall magnetic pole. Another interesting thing about our magnetic poles is that it seems, based on some scientific observations or evidence from studying rocks and the arrangements of magnetic particles in them, it seems that our magnetic sphere, our magnetosphere, has changed directions periodically over history. We have got magnetic reversals that occur. So instead of the North Pole being the north, the pole of our planet has actually been in the south. And we've actually seen where this is reversed numerous times over history based on studying evidence with regard to rocks that have formed from out of lava. And actually we are in a time frame where it looks as if it has been a very long period of time where we have had magnetic north. And so at some point we may see where there is a magnetic reversal, maybe even in your lifetime. Imagine what would change based on the fact that all of a sudden you woke up one day and instead of the North Pole being north, or true north, magnetic north, excuse me, being north, instead it was to the south. It would be kind of an interesting change in one day. Would it change migration patterns of birds? Do birds rely on the magnetic poles of our planet to know which direction's north and which direction's south? So it could cause some changes in ecosystems.
Earth has a magnetic field, as proven by the action of magnetic compasses. This field surrounds the entire planet. Earth's magnetic poles are located near, but not exactly at, its geographic poles. Because opposite magnetic poles attract one another, the north pole of a compass needle points toward the south magnetic pole of Earth. Therefore, Earth's south magnetic pole is located near its north geographic pole. The reason for the existence of this magnetic field is not fully understood. One theory is that the field arises due to the movement of electrically charged ions or electrons carried along by convection currents in the liquid portion of Earth's core.
Earth's gravity. Gravity is the force of attraction that exists between all matter in the universe. According to Newton's law of gravitation, the force of attraction between any two objects depends on the masses of those objects and also the distance between them. So if we have two objects that are fairly large, two bodies in our solar system that are fairly large, that are in close proximity, they are going to have a greater gravitational pull on one another. The same thing works with regard to objects on our planet. A truck sitting in the parking lot has a gravitational pull that is greater than what you do. Okay? Because the mass of that object is greater. The larger the masses of two objects and the closer together the two objects are, the greater the force of gravity between the two objects. Weight and mass. Weight is a measure of the strength of the pull of gravity on an object. You're all familiar with weight. You step on a scale and it measures the force of gravitational pull on your body based on the amount of mass that you have. So an object's weight depends on its mass. The larger amount of mass that we have, the larger our weight is going to be. Weight and location. Because the distance between Earth's surface and its center is greater at the equator versus that at the poles, the weight of an object at the equator is about 0.3% less than the weight at the North Pole. So if you were to stand on the North Pole, you would weigh about 0.3% more than you would if you were to take a plane, fly all the way down to the equator and stand on the equator. The four spheres of our planet. Matter on Earth is in solid, liquid, and gaseous states. We've talked a great deal about this in the past. The Earth system is composed of four spheres. Those four spheres are storehouses for all of the matter and also the energy on our planet. The first sphere is the atmosphere. Remember, an atmosphere is a mixture of gases that surrounds a planet or moon. It provides us with the air that we breathe, with the oxygen that we need in order to go through the respiration reaction that occurs inside of our bodies. It also helps to shield us from the sun's radiation. So we have an ozone layer that protects us from ultraviolet radiation that is harmful to our cells. Our atmosphere also produces weather. It gives us precipitation, which is going to be important for the living things on our planet. The hydrosphere. Hydrosphere is the portion of our planet that is water. Remember that water covers 71% of our surface. The The hydrosphere includes any body of water, whether it be oceans, lakes, rivers, streams. It could be frozen water like glaciers and ice sheets, and it also includes groundwater. So in the past, we've talked a great deal about different forms of water and where it's found on our planet. The hydrosphere is that area that is water. Anything that is made up of water or has water that is held in it is considered part of the hydrosphere. The geosphere. The geosphere is the mostly solid, rocky portion of our planet. It extends from the center of the core all the way up to the surface of our planet, the crust that you're standing on. It also includes all the soil that we plant our crops in. And it also includes all of the rock and material that are underneath the oceans. The geosphere also includes the molten interior of our planet. So it doesn't necessarily have to be solid rock in order to be considered the geosphere. It can be molten rock in order to be considered the geosphere as well. The biosphere. The biosphere is part of Earth where life exists. It includes all of the living organisms on Earth, as well as those organisms that consist of organic matter that has not yet decomposed. So go back to that picture real quick. That guy right there is still considered part of the biosphere. Many of you probably see deer like this periodically as you're driving down the road currently. This time of year, most biological reactions due to the temperature outside with regard to bacteria have slowed. So those organisms don't break down very much during the winter time. And basically the snow plow just continues to pile snow on them and drive them farther up in the bank of snow on the side of the road. That deer is dead. He is frozen. He is solid. He is not decomposed, therefore he is still considered part of the biosphere.
There was one down by Rainbow Lake, I guess, yesterday or the day before, where they took a stick or something after someone hit it, stuck it up there, this little baby one, and they were just sitting out there right by the road. It looked like it was going to go out in the middle of the road. It was turning everything.
The biosphere extends from the deepest parts of the ocean to the atmosphere a few kilometers above the surface. So when we think about the things below the Earth's surface, insects, earthworms, a number of larvae for different things, all of those organisms that are found within the soil are considered part of the biosphere. We also think about birds flying in the air, or parts of microscopic organisms like bacteria that are floating around in the atmosphere as well. All of those are part of the biosphere. Yes, they are in the geosphere. Yes, they are in the atmosphere, but they are not considered the geosphere or the atmosphere.